Yes, here. Okay, it's started. And okay, thank you. Because all of these uh, sessions and the first four sessions are explanatory, and all of them are according to the slides. Because of that, I didn't want to record it because, as I said, my system has a bug, and when I start to record the session, actually the interrupt will happen after 10 or 15 minutes, and because of that I didn't want to make interrupt, because all these materials are explanatory, and if you have a only review about this slide, you can find everything. There isn't any extra thing that I'm explaining about them. Only the slides content are explained here. And as you see, as I said, the first 96 location address the register file, and 64 location address input output memory register, and the next 1024 location address the internal data SRAM. The other memory of Atmega 16 is EEPROM data memory. Atmega 16 contains 512 bytes of data EEPROM. From previous sessions, you know that what is EEPROM? It is electrical raisable program RAM memory. It is organized as separate data space in which single bytes can be read and written. The EEPROM has an endurance of at least 1,000 write and erase cycles. And I want to notify something here. As you see about EEPROM, we have 100,000 write and erase 6. Also about in-system programmable flash program memory, we had only 10,000 write and erase cycles, and it means that the EEPROM has a preference with respect to flash memory type of memories of 16 Atmega 16 memories. After talking about different memories of Atmega 16, I want to have a review about reset sources of Atmega 16. Actually, we can say that a microcontroller needs to be reset to get to a known state before program execution. Reset is typically generated by a hardware signal from external sources. For example, you might find a reset button on the development board. But most of microcontroller devices have an input pin for reset, and actually if a low level will be on reset pin for longer than the minimum pulse length, it will generate a reset. There are different reset sources about Atmega 16, and with respect to our application, we can use them. One of them is power on reset. The microcontroller is reset when the supply voltage is less than the power on reset threshold. Another one, another reset source is external reset. The microcontroller is reset when the reset pin which is pin number of 9, is grounded. If you consider the microcontroller datasheet, according that the reset pin number, external reset pin number, is 9, and for applying reset, it should be grounded. Another reset source is a watchdog system reset. The microcontroller is reset when watchdog timer period expires and watchdog system reset mode is enabled. Watchdog timer are used to facilitate automatic correction of hardware faults and to prevent errant and malevolent software. During the during a normal operation, the microcontroller regularly restarts watchdog timer to prevent it from elapsing or timing out. And when it's required, by using the watchdog reset, we can reset the microcontroller. Another reset source is a brownout reset. The microcontroller is reset when supply voltage VCC is less than brownout reset. Okay, I think we finished the experimentary part and the different components of a microcontroller. We explained about the architecture of AVR microcontroller, different families of AVR microcontroller, and also different specified properties or features of Atmega 16 and 32. We explained about them, and now according to the syllabus of this course, I want to have a review about C language, and then we'll start to our coding. However, according to the syllabus, I should explain about the only coding and the rules related to the coding, but because about this course, as I talked in first session in the conference room, for the ones who was attended to that class, I said that because we don't have laboratory classes, and it is really bad for the students who wants to learn about microcontroller course. I prefer to have a simulation class for you, meaning that at first part of the class, in next sessions, I will talk about the rules of coding and then start to screen sharing with you for simulation part. And I will say you to download the applications and softwares related to the discourse. Next session or the session after that, and all of you should have these two applications. Actually, two applications or two softwares are required for us for having coding and simulating different applications by using our microcontroller. And our final exam, because we don't have laboratory classes, will include the simulation and coding in related softwares. Then now I start to have review about C language. However, I know that for computer engineering students, this part is so easy, but because electrical engineering students as a microcontroller course are added to this class, I should have review about C language, and it is a part of our course syllabus, and we can't delete this part, and it would be so useful for all of the students. Actually, C language is a middle-level programming language which can be used for programming of AVR microcontrollers. Then, as we talked in first session, we will use C language for our coding. Some of the advantages of C language to assembly are actually noted here. C syntax is a lot easier to learn than assembler syntax. And it's easier to use for making more complex programs. Moreover, C language is a lot more flexible and portable, meaning that by small changes in the program of particular AVR, you can use that program for another one. It means that the architecture of AVR don't require for programming. And while we don't have such opportunity about assembly language, and assembly instruction depends on the processor architecture, then we can say that C language or C syntax is a lot more flexible and portable. Moreover, it has we have availability of library and functions about C language. Only the advantage of assembly to C language is that in using particular instruction, assembly code's volume is lower than C language, but by considering all of these advantages, only one advantage of assembly language can be ignored. Okay. Now I want to talk about basic syntax of C language and different signs, different types of code and coding in our C language. Actually, first rule involves the use of semicolon. Semicolon signs, I'm sure that all of you are familiar with this sign. Every command in C language must be end with a semicolon, except the statements. Yeah, I was waiting for that. And as I said, when I start to record the sessions, this problem has happened, unfortunately. Then we will wait for 5 or 6 minutes, and after that, after solving problem, we start again, okay? Okay, could you please say something about my voice quality? Okay, okay, thank you very much for letting me know about that. Then again, we'll continue our discussion and explanation. As I said, first rule involves the using of semicolon. About C language we are talking for the ones who recently or attended to class and we should use a semicolon at the end of each command, meaning that every command in C must be ended with a semicolon, except the statements which start with number sign. Here, as you see, this is a command, a part of our coding. A is equal A plus B, and after that we have semicolon. If you don't use semicolon, your program or your coding will give error. Commands are like helping. There are some commands which are like helping text in your C program, and they are ignored by compiler. They start with slash line star and terminate with the characters of star slash line as below. For example, this is a helping test or is an extra explanation in your coding, and actually, as you see, it is limited between slash star and star slash, meaning that the compiler actually don't execute this explanation when it is inside these two characters. Moreover, when we want to use helping text or explanation text that we don't want to be executed by compiler, we can use double slash, but after that only one statement should be used. And if we want to use more than one statement, we should use this character. So about C language, it is possible to write more than one statement in one line of program. For example, as you see, A is equal A plus B, semicolon. Don't forget semicolon, and you should be so careful about using semicolon. And the other program, the other code or command is C is equal A minus B, for example, and by using semicolon. As you see, we can write more than one statement in one line of our program. One statement, the second one, but by using semicolon after each of them. About curly braces, the program or the code which start with curly braces, this is curly braces. It should be enclosed with that too. If you don't use at the end of your code, which is started by curly braces, if you don't enclose it by curly braces, your program will have error and will not be executed by the compiler. For example, as you see, this is a code. As you see here, we used curly braces and we enclosed it by curly braces too. If we don't use this one, our program, our code will have error. About C language, each variable must be determined before using that. For determining of variables, we can use letters, numbers, and also symbols like underline also can be used. But note that using a number in the first of the name of variables is denied. Moreover, using special words of compiler like class, define, if, and another special words related to the compiler that you will be more familiar with them in next sessions are not allowed to use for defining or determining the variables. There is another sign, which is $sign, is also denied for naming of our variables. Moreover, using space in the names of variables is not allowed. Meaning that if, for example, for naming of the variables, if you use space between the letters or your naming of variables, you will have error in your program. About numerical variables, they can be determined by these three ways. When we are trying to use the numbers related to the different numerical variables, we will have different rules. For example, I used X for naming my variable. For decimal number, as you see, I only wrote X is equal to 225, for example, any other number, but decimal number. As you see, I used the double slash line, and after that I use decimal. What does it mean? It means that the compiler don't execute this statement, and also and only it is explementation statement or extra helping text statement. Okay, for determining the decimal number variables, as you see, we name our variables and then use our decimal number. But about the binary and the hexadecimal is not the same. For example, I used again X variable for naming my variable or determining the variable. And this is a binary number. Before binary number, for determining binary variable, we should use 0b as prefix. And about hexadecimal numbers, this is double F is hexadecimal number, as you see. And before determining hexadecimal numbers, we should use 0x. Then you should be so careful about determining numerical variables, especially about binary and hexadecimal numbers. Before binary numbers, we should use prefix of 0b, and before hexadecimal numbers, we should use 0x. Here, as you see, there are C programs, C program basics. Each C program is starting with the preprocessor. Here you see that a code or a statement which is starting with number sign. We said that any kind of command which is starting with number sign, after that we will not use what? Semicolon. As you see, we don't have semicolon. here. This is a preprocessor command that includes the standard input-output header file. This is a standard header file which is related to C library. And it should be used, this preprocessor command should be used at the first of any kind of C program, and before compiling a C program, it would be compiled. And any processor is including a header file. It can be related to C program header file. As you see, stdu.h is related to a library of C language, or the header file can be can include the AVR header file libraries, and you should be most familiar with them in next slides or sessions. Then you learn that each C language is starting with preprocessor, which is including number sign, then include term. All of them are including include term, and after that header file, which can be related to C program library or AVR header files. About the basics of C language, we will have a main function. Here we have our main function, and if exactly from here, execution of any C programs begins. I explained about curly braces. This indicates the beginning of main function. This is starting our C programs, and after that, as you see, we will use curly braces. And as I explained, after using curly braces, at the end of our coding, we should enclose it by using curly braces. If we don't do it, our program or our codes will have problem. I explained about helping text, and I said we should use a slash star or double slash for one statement. You're familiar with this part. I explained in a previous slide. And then there are our commands. Actually, for example, here we have a printf command. There would be different kinds of commands, but these are the basics of C programs. As an example, I'm explaining about them to be familiar about the routines of writing a program in our coding. For example, printf command prints the output onto the screen. Suppose that we interface the LCD to our microcontroller, or on the other hand, we used our microcontroller for interfacing with LCD, and now we want to print a statement as hello world in our LCD screen. To do that, we use this, for example, this code printf, then parentheses. Inside parentheses, by using semicolon, quotation mark, sorry, by using quotation mark, we write our desired statements. For example, welcome to Istanbul, or hello world. Any kind of statement you can use inside quotation marks. The other part of our coding, for example, gauge, this command awaits for any character input from keyboard, and then return 0. This command terminates C program's main function and return 0. And as I said, curly braces, which indicates the ends of main function. As you see, our main function is starting of our C program. It's after that we use curly braces, and then after using different type of commands relating to printing something or getting something or waiting for any kind of input, we use return code, and after that again the curly braces is used for enclosing our program. Here the same example, a sample program with our previous slide, which I explained about them one by one, are used as a unique form. This is a code which is used in our programming, is a real code that we use it for programming our AVR microcontroller. As you see, it is including preprocessor. The preprocessor, as I said, I'm trying to explain about it again to have a general view about it. Then about the codes, you will be familiar more when we are starting. We will start to our coding. You will be familiar with different kinds of codes and preprocessors. So here, as you see, this is a sample program. As you see, it's starting with a preprocessor. It should be started with a preprocessor. Number sign, include term, and header file, which is related to our C program. Then our main function. After using main function, curly braces and enclosed curly braces, the experimentation statement, which is limited or surrounded by this sign, /star signs at the first and end of our explanation, which is not executed by compiler, and our code printf. I said that we should use parentheses, and inside parentheses we use quotation, and then our statement that we desire to write or to print in our, for example, LCD screen. Note that if you don't use quotation marks, your program will have error. And you see that after these codes we used this command, we used semicolon, and again return 0 and semicolon, and enclosing our program. Now I want to talk about the variable declaration, and then I will introduce the different applications or softwares which are required for this course, and then I will finish this session too. As you see here, we have a variable declaration: bit, char, unsigned char, signed char, int, short int, unsigned int, and signed int. And the rest of that is in this slide: long int, unsigned long int, signed long int, float, and double. You see that all of the variables, types, size, and range are given here. When we start to our coding, you will be familiar with the usage of all these types of variables, and you should be more familiar with variable declaration, but it's necessary to have information about using them. Actually, in C programming, variables which are to be used later in different parts of the function have to be declared. Then we need to use to have variable declaration, and variable declaration lets the compiler two things: the name of variable and the type of data that variable will hold. For example, char, as you see here as second row, is used for letters. So when our variable types is letter types, at first we should use char for declaring our variables. Or for example, int as a fifth row, as you see, it is 16 bits, and it's used for integer numbers. For example, if we want to declare variables which is integer number, at first of that variables we should use int, and there are different types of int: short int, unsigned int, and signed int. For example, if we want to use integer number which is signed and 16 bits, and its range is in this range, we should use signed int. As you see, its range is here. And also for long int, we have long int for high lengths of integer number. As you see, it's including these numbers. And also double and float are used for real numbers. As you see here, they are including real numbers. So we understand that our compiler needs to have a variable declaration for what? Because by a variable declaration, we are telling the compiler the name of variable and the type of variable. It can be integer number. If we want to declare integer number, we use int, and different types of int related to be unsigned, signed, and its range of our number. And we can use, for example, char when our variable type is character or letters. And we said that for using, for declaring variables kind which are real numbers, we should use a double or float. For example, suppose that you have a real number, and if you use the, for example, signed int, unsigned int, or any type of int variables, your program will not be executed and you will have error, or your compiler will not execute the program because your variable declaration isn't correct. Then, for example, when you're using real numbers, you should use float or double terms for variable declaration. Okay, this session also is finished, but I want to introduce two applications that for next session, or I think after one session, we will start our coding. As I said, I'm sorry for more explanation, but it is the nature of this this course, and it is a part of syllabus, which according to a strategy of each of the courses, we should explain about them. And I can't omit it because it is the part of your course syllabus. You should have sufficient information about at first about the microprocessor and microcontroller, its inside and architecture, its different components and the features, properties, different information about the pins of your considered AVR. That about this course, we said that we are considering AVR microcontroller from Atmega 16 or 32 category or family. But after passing this session, we will start our coding, which is our main part of our course and interesting part of our course will be started. Please, for next session or the session after that, download and install Produce and CodeVision in your PC or laptop in your system, because the homeworks, if we have and midterm exam and also final exam, will be based on coding, and I want you to install these two application in your system to having sufficient exercise, and actually, as I said, your final, especially your final exam, will be based on coding, meaning that you I want to interface, for example, one of the application with a microcontroller, and then start to coding your desired codes in the AVR microcontroller at Mega 32 or 16, and execute the program. Your coding should be completely correct, because you will have a simulation application in which you simulate different applications or different devices interfacing with your microcontroller, meaning that you will have wiring in that application, Produce application. It is an environment of simulation, and CodeVision is the environment of coding. You should you start a program in CodeVision and then interface with simulation software, which is Produce, in which by using the wiring you interface different application with your microcontroller, and then by merging these two applications with each other, your program will be executed in your application, for example, SCD, keyboard, or any kind of application that we will have according to syllabus in next session. Then as an email, I will send the exact name of the name of application or softwares to all of you. Please try to install it in your system, to we can cooperate in next session with each other by coding, and I try to have screen sharing with you to can compensate our lack of library laboratory sessions, and can have sufficient information about programming of our microcontroller and executing it in a virtual application. Okay, do you have any question? Yes, of course. I didn't upload the slides previous session. Are you sure? But as I remember, I upload them for all of the students and send as email in OIS. All of the students have the same problem, meaning that you didn't you didn't receive the previous session's lecture. Please let me know about that. Oh, sorry, but yes, I send it by OIS email. If you check your OIS email, you can see that I send every session after finishing the session. I try to send these slides a PDF to all of the students. If you check your OIS email, you can find them. However, because some of the students didn't receive the previous sessions. Slides, I will send them again by merging or by adding to this session's PDF file lectures. Okay? Do you have any question? No question? Okay. Thank you very much. And this session is also finished. From next session, hope that we can start to our coding, which is the main part and interesting part of our course. Thank you very much. Have a nice time. Bye bye. See you soon. Bye bye.